Hello and welcome to this episode of Ask a Consultant, our frozen soils heating up your solar project. I'm Brett Gruber, Director of Renewable Energy and Infrastructure at Braun Intertech, and joining me today is Rock Player. He's the Vice President of Technical Practice for our Engineering and Testing Services Division. And today we will be talking about the importance of frost mitigation considerations for design and installation of pile foundations on solar projects. So Rock, would you mind introducing yourself?
Sure thing. I'm Rock Player. As mentioned, I've been in this industry over 25 years. And as part of my experience, I've had the opportunity to assess, analyze, and design deep foundations in terrains as diverse as the North Slope of Alaska down to the southern tip of Texas. My first professional engineering license was in Alaska, and so I have quite a bit of cold regions experience. And frost jacking and the impacts of freezing soils on solar panels or something we want to share our thoughts today and how we can better help you with this.
Thanks, Rock. I'd like to start by talking about some definitions and some mechanics. So if you could, why should solar developments care about frost heave?
Well, there's a couple of different points to that. One is the northern latitudes, and the cooler temperatures are really conducive to better electrical generation, and with the studies that I've read. And so as a result, solar farms are being planned in areas where frost is an issue, where frost depth can impact the design of the foundations. And with the number of piles, the thousands of piles that may be as part of one of these solar installations, every foot on that pile can add additional costs, and any other mitigation methods that are needed for dealing with frost can add cost. And so owners need to be very aware as they move into designing and installing solar arrays in cold regions of what the impacts are.
Sure. So can you dive in a little bit deeper on what is frost heave?
All right, frost heave is, we often hear the word frost heave, frost jacking, and add freeze, and sometimes they're used interchangeably, but there are actually three different parts to what all can impact the a solar installation. Add freeze is simply that bond between the pile and the frozen ground. Frost heave is where, when soil freezes with moistures, because ice when it freezes, expands volume. As ice lenses form, it can cause volume increase and raising of the soil. That's the heave. But when the two work together, add freeze and frost heave, that's when you get frost jacking. And frost jacking is where the ground, because it's frozen to that element, is trying to jack it out of the ground. And so with that can cause issues such as misalignment of the racks, and can cause, at the best and at the worst, it can cause damage actually of the panels through the differential movement of the racks by the frost activities.
Understood. Thank you. So when we're thinking about that, how deep does frost penetrate?
Well, it really depends upon the site, and it's a multivariable equation that has to be evaluated by the professionals that the developers have hired. It's a combination of three things for frost heave to occur, and the resulting jacking. You have to have freezing temperatures, frost susceptible soil, and access to water. And if you can take any one of those things out, you can take frost away. But the presence of those different things also change the depth of frost penetration. So in areas like Austin, Texas, 6 inches. Areas like northern Minnesota, you can have, depending upon the site, you can have 8 to 10 feet. Alaska, we had places where we had 13 to 15 feet of frost penetration during the course of the year. So it varies by the site.
All right, Rock, how do we determine depth of frost?
To determine the depth of frost penetration, it's really a thermodynamics problem where we look at heat transfer from the ground to the air. It's dependent upon how long the air is below freezing, and then it looks at the insulative value of each layer of soil and how heat transfer the soil and changes from gas or liquid phase of water to frozen. So for organic soils that have a high natural moisture content. They have a high insulation value, and it's going to take a long time for frost to penetrate through them versus a drier soil with a lower moisture content, like a gravel. And so look at it as a multi-layer system, and look at how that freezing front crosses through the ground down, and see how far it can penetrate during the time of frozen. So I have to understand moisture contents, have to understand soil types, which are dependent upon a good site investigation, and then the time at which the air is below freezing.
Understood. Thanks, Rock. And I think it's important to note that there's maximum values that we can reference. There's average values, median values for frost depth that we can reference. And really, it's working together with that owner, with the foundation designer, and us as geotechnical consultants to really understand what's the risk tolerance as far as moving on that pile. Understanding that being too conservative could kill a project just as easily as a bunch of piles blown out of the ground. So I think it's important that partnership be established early, and in that common ground is found as far as what does success look like, what can we live with as it relates to pile movement, and from there develop our recommendations. Can snow cover or vegetation cover, can that impact frost depth at all?
It does, because different materials have different thermal properties. And soil, organics, particularly highly organic soil, vegetation has a much higher resistance. It's more insulative than sands, silts, or clays. Snow also has great insulation value. So with the presence of an organic layer and soil can reduce the depth of frost penetration remarkably. In the same terrain, same soils, if you clear the soil, your depth of clear the soil and clear the snow, your depth of frost penetration will be much deeper.
Sure. And when you think about a project that is a life cycle or a lifespan of 20 plus years, we're repowering solar now. There's going to be a lot of cyclical changes year to year on snow, obviously how cold it gets in a given year, how much snow we get. So that's probably an important piece to discuss with your geotechnical consultant on a project that you're considering.
Absolutely. Most places in the United States, there are tabulated climatological information that will help in the assessment of the potential for frost penetration. They're regionally built, but also a little bit site specific. So they're very good sets of data, but they're based on data from historical weather stations. And so, your consultant who's helping you through this needs to be aware of where that information is and be able to look at that information, make sure that it's still pertinent for the location that you're at. And then with that, also a detailed investigation of what the soils are, what the water sources are, can really help through that upfront investigation through a trusted, experienced partner, help to mitigate the long-term costs, both upfront installation as well as long-term maintenance.
All right, thanks, Rock. So how does frost act on a pile? Over what length is that frost acting upon the pile?
Well, frost acts upon the pile really dependent upon, of course, the depth of the frost penetration and the soil type that's there, because different soil types and moisture contents have different ad-freeze values. At the ground surface, it's the coldest, and then it gets warmer with depth until you get to the bottom of that depth of freezing. And at the very bottom of the depth of freezing, the temperature in the ground is 32 degrees. And so it's beginning to freeze, but the adhesion of a 32-degree soil versus, say, a 15-degree soil is lower. And so when we look at the depth along which frost acts on the pile, we need to take consideration not just the depth of freezing, but the temperature of the freezing as well. Because it can be, depending on the soil type, overly conservative if the frost depth is down to, say, 5 feet, to use the full 5 feet. If the bottom of that 5 feet is 32 degrees, and it'll creep rather than hang on to that pile. And so it's a thermodynamics problem, but ice, when it's colder than -4 degrees centigrade to mix units, it behaves differently than between 0 and -4 degrees centigrade. And if we just treat it all as the same, well, then we can add unnecessary conservatism to the analysis. The other thing we need to take into consideration with that when considering depth of frost penetration and where to do it, so we need to look at the lumpiness of the freeze-thaw cycle. The calculations that are done typically to determine depth of frost penetration basically assumes that it's going to be frozen from this time to this time. It's freezing at index freezing days. But with climate change and with just the natural cycle of things during weather, it's not going to be cold, stay cold, warm up. And so coming with a trusted partner who understands the climate, understands how it behaves, the freezing and thawing of the soil, also can site-specific get to a point where you're looking at being more realistic of how it's behaved and what's the depth that's going to be there. And then the soil type. Silts and clays will have a higher adhesion value than sands and gravels. And so we look at that as well. So it's not just depth of frost penetration, but it's that adhesion value that it has to be considered. So it's, again, moisture, it's temperature, soil type, and moisture. And as we look at those three things, we can better understand the true depth of frost penetration that is causing ad freeze that will lead towards frost jacking and adverse performance on the piles.
Okay. All right, so now we know how frost acts on a pile and how it can affect the development of a solar installation. What can be done to address or mitigate frost heave?
Well, I think the first thing is have an experienced partner that that the owner can collaborate with and partner with to truly understand what are the conditions for success. So if a soil can, or if a rack can move a certain amount, well, then that needs to be considered within the analysis. That if zero movement is the standard, address it one way. If an inch of differential movement is another standard, it can be done another way. So the owner and their partner needs to establish very clearly what are success metrics, what looks like success on that project, short and long term. And then we're dealing basically with forces. We have to, with whatever the foundation is in there, provide enough resistance in the foundation to accommodate the forces. So of course there's the axial loading from the rack and the panel. That's generally lower than the wind load that's trying to uplift that panel. And so we have to design our foundations to accommodate that. An additional load we have to accommodate is that which is due to frost jacking. And so understanding that load better will allow us to be more efficient in the design. And so we have to look at that. Okay, what can we do to that? We can either accommodate that load through foundation. We can reduce that load due to bond breakers, due to changing the soil around that pile, like over digging it and backfill with gravel, then putting the pile in, because that can reduce the adhesion. Have to be careful though, because if it becomes a bathtub and it's full of ice and gravel, it's worse. You could use coatings on the pile that have a lower adhesion value when the surrounding soil freezes to it. And then the other thing is you can reduce the depth of frost penetration. So it's preserving vegetation. It is using insulation, pink board stock on the ground around the piles can reduce that penetration. You can look at heat trace. I mean, there's lots of different things you can do to reduce the depth of frost penetration, but they all come with cost. So our job with the developer is to work together to come up with what is the most cost-effective path forward that will minimize as much as possible the upfront cost associated with dealing with frost, and also look at the long-term effects of spending dollars now versus spending dollars later in maintenance and refab and rehabilitation. There's been lots of studies about spending dollars up front, that for every dollar that's spent up front in good investigation, study, and addressing the geotechnics can save $5 to $10 down the road in construction costs. So again, teaming with that partner is probably the biggest thing that an owner can do to be able to reduce their upfront cost and have a more effective program going on out there. Another thing, just to make sure that all are aware of, is with that partnering, cheaping it out up front, going with a low cost provider that provides low value support up front will inevitably add costs to the project, both in the short and the long term. So test sufficiently, both from a load test out in the field, but as well as investigation soil test to understand the type of soil that's out there on a more of a granular basis than one boring every 2 acres that have to design for the worst case. Take the time and make the investment to design your solar installation to meet the site conditions, rather than trying to superimpose a typical onto a site that then ends up costing more, both in the short and long term, because it doesn't match with the conditions of the site are at that time.
Understood. So I think what I'm hearing is tailor your approach to the site and the region you're working with, that your geotechnical consultant, a good one, will be able to help you develop an appropriate scope. One size doesn't always fit all. Secondarily is longer pile isn't always the only option, whether it be, like you said, frost mitigation, or different foundation types to consider as well. So, all right. Well, I appreciate your time, Rock. I really enjoyed the discussion. I learned a lot, and I'm sure our listeners got a lot out of it too. And really, if you can't trust a geotechnical engineer named Rock, who can you trust? So to our audience, if you have any questions about your renewable projects, we can help you. Just fill out the form to the side of your screen there, and myself or one of our consultants will receive that and be in touch with you very quickly. Thank you.